Okay, you can try this question. The question goes like, in figure 4.16, you support the pulley system with your hand at rest. If you have your eyes closed and think that you are instead supporting a single mass at rest, what is M in terms of M1 and M2? So that's the question. So the meaning is, you first of all you need to find how much tension you will be feeling. So once you recognize how much tension you will be feeling, then you can see like effectively how much mass you will be feeling. So for that, this is the question. Now if it is at rest, then you need to find what is the tension in this string. Now there is a pulley, there is mass M2, there is mass M1. Now this is a very basic question from Newton's laws. So what you will be doing, you will be drawing a free body diagram, which I clubbed it here. You have to draw this one separately, this one separately, this one separately, this one separately, right? So anyway, I clubbed all those. Now the first thing is, how many forces will be acting on this M2G and tension. Now the thing is, if this tension is T, I assume tension at every part in the string as T. Now why it is? Because the string is massless. Because of the string is massless, tension is same at every point here. Now if this tension is T, I assume this tension is also T. What is the reason? The string is massless, as well as there is no friction here. Now that is also one more assumption. I mean ideal situations, right? So if this tension is T, then this tension is also T because the string is massless. Now the force here is M1G and T. Now if this is T and this is T on the pulley, this will turn out to be 2T. What is the reason? The pulley is massless. The pulley is massless. So if this tension is T, this tension is T, then this will be 2T. When some mass is 0, then the net force on it must be 0 and net torque on it must be 0. At least in physics questions, because or else it will be having infinite acceleration or infinite angular acceleration. So whenever there is some massless thing, net force on it must be 0. Now again, if this tension is 2T, the tension at every point on the string is 2T because the string is massless. So what are the assumptions? Strings are massless and frictionless, and pulleys are also massless. That's the thing we have taken. Now I will be writing F equal to MA for this one, So I will be assuming this will go down, this will go up. So M2G minus T equal to M2G minus T equal to M2 into its acceleration. T minus M1G equal to, it is going upwards, right? So T minus M1G equal to M1A. But what I have done here, I assumed both accelerations are same. What is the reason? I am going with one more ideal string property, that is string is inextensible. If string is inextensible, at whatever, if this distance goes down by distance x, if this one goes by a distance x, then this one also will go up by a distance x. So if this acceleration is a downwards, this acceleration will be a upwards. So that's the reason I took both accelerations are same. So when you solve it, you will be getting acceleration as this much. When you substitute that acceleration, you will be getting tension as this much. But what we need 2 times of tension, because we are holding here. Instead of sealing, we are holding it. So what is the tension we will be feeling, which is 2T? How much its value? 4M1 M2 by M1 plus M2. So this is the tension force what we will be feeling. So instead of that, if someone keeps a mass M, but if we want to feel the same tension, so what must be that mass? That mass must be equal to 4M1 M2 by M1 plus M2. So if someone asks you to hold this or this, when this mass is 4M1 M2 by M1 plus M2, you won't be finding any difference. You will be feeling like, if you have closed your eyes, you will be feeling both are same. Effectively, what I can do, whenever there is some system like this, I can replace this entire thing with a single mass whose mass is 4M1 M2 by M1 plus M2. Right, equivalent mass. Now based on that, you can try this question. Consider infinite Atwood's machine. A string passes over pulley with one end attached to mass and other end over pulley and stuff. So it is the same thing, the same pattern is going to repeat again and again, right? Infinity, till infinity. Now okay, first of all I will be going with what we have done. So what we have done, in infinite series, the first thing you have to do is you have to see like which pattern is repeating again and again. What is the pattern that is repeating again and again? This pattern. Now you can see this pattern is same as this pattern. So you can see whatever is there in red box will be same as whatever is there in blue box. So if I can assume that I can replace this entire thing with a single mass, some capital M, I can say I can replace this entire thing also with a single mass, capital M. But okay, anyway, let me go for this one. So I am replacing this entire thing with a single mass, capital M, and this mass is small m. So what I can do, I can replace this entire thing with 4 capital M small m by capital M plus small m. So I can replace this entire thing with 4 small m capital M by small m plus capital M, when this is capital M and this is small m. But what we know if this is capital M, then this also has to be capital M because the pattern is repeating again and again. So when there is capital M and small m, I can replace this entire thing with 4 m1 m2 by m1 plus m2, but that entire thing is again capital M. So from there I can cancel capital M and I can get capital M as 3m. So once I get capital M as 3m, then this is going to be 3m and this is going to be m, which is going to be the previous question. There are two blocks, one mass is 3m, one mass is m, then acceleration will turn out to be m2g minus m1g by m1 plus m2, which is g by 2. So that's the extension. The other way of solving it is, again, there is no single method. Now you can see here, for the first pulley, the FBD looks like this. If I take this tension as t, this will be t, this will be t, this will be t, this will be 2t. Now if this is t, this will be t, this will be t by 2, t by 2, t by 2, t by 2. Now if this acceleration is a upwards, this acceleration will be a downwards. So let me assume acceleration is a upwards, so this will be a downwards. Now this tension must be a function of these masses. Now for this pulley, whatever is this downward system, for this pulley also the downward system is almost same. So this tension must be proportional to that mass factor, and the geometrical structure is same, so the mass contribution will be same. So I'll be just looking at how it is related to acceleration due to gravity. So this tension must be function of mass as well as acceleration due to gravity, but that function of mass is going to be same if I observe from this pulley or this pulley, because this downward pattern is same as whatever is for this pulley, it's same as for this pulley also. So I can say this tension is proportional to G. If I say, then this tension, if this tension is proportional to G, then this tension, which is T by 2, has to be proportional to G minus A. How I can say that? When I observe from this pulley is going downwards with acceleration A. So when I observe from this pulley, effective acceleration will be G minus A. So when I observe from this pulley, it's same as observing from this pulley. But what is the difference? The tension here is T and acceleration due to gravity is G. But when I observe from this pulley, the tension is T by 2 and acceleration due to gravity is G minus A. So when I take the ratio, I will be getting the required answer, whatever method it is. So the next question goes like, okay, anyway, you can read the question and you can try. So what I am going to show here is, if there is friction between pulley and string, fixed pulley, if there is friction between pulley and string, then the tension is not going to be same on both sides. So this is what I am going to say. You can solve the remaining part of the question by yourself. Now if it is moving, if it is just sliding, so then the friction has to be maximum. So I am going with just sliding case, that is going to be easy. So what I will be doing, I will be taking some element, I will be trying to see like what is the friction acting there, so that I can find what is the total friction. So that total friction will give me what is the difference in tensions, right? So what I am doing is I am taking some element at an angle theta, I am taking some element here whose angle is d theta, and this is the midpoint of that. So this is d theta by 2, this is d theta by 2. Now if it is sliding this way, then this tension will be more than this tension. Now it is a massless string, so its weight is not put here, but there will be normal reaction from the pulley, right? So this angle is going to be, this angle is d theta by 2, so this angle is d theta by 2, this angle is d theta by 2, so this angle is d theta by 2. So you can see what is the net force along this direction. Now apart from this tension and normal, there will be friction also. You can see that easily because this is t plus dt, its component will be more than this t dt, so friction has to come into picture, right? So if I try to write what is, okay, I will be trying to resolve into two perpendicular components. One is along the direction of friction, one is along the direction of normal. So if I resolve them along the direction of normal, dn is equal to this t component plus this t plus dt component, which is t sine d theta by 2 and t plus dt sine d theta by 2, right? So that's the first equation. From where I got this equation, by making net force equal to 0 along the normal. So from there I can see that angle is small, so sin d theta by 2 I can replace it as d theta by 2, and this is going to be very small, so I am going to neglect it. So normal is almost equal to t d theta. Now apart from that, I can make net force equal to 0 along this direction also. The reason is, when something is massless, then the net force on it must be 0 irrespective of what is its acceleration. So t plus dt cos theta by 2 equal to t cos d theta by 2 and df, right? Or the net force equal to 0. So from there I will be getting cos d theta by 2 is almost 1, right? So from there I will be getting dt equal to mu times of dn. So these are the two things. One is dn is I got this much, dt is I got this much, but dn I am going to substitute here so that I will be getting two variables. So when there are only two variables, I can integrate them easily, and I can see it will turn out to be t2 equal to t1 times of e power mu theta. E power mu theta. Now what is theta here? In this particular question, theta is this total angle in contact, which is pi. So the more angle of contact, the more friction it is going to be. So the more will be the ratio of tensions, the more will be the difference of tensions and stuff, right? So what you understood here? You understood the more number of rounds, the more friction it is going to be, right? So if you want to hold some heavy object, what you can do, instead of holding like this, you can see some some pulley kind of thing, or like some rod, and you can roll different number of tons of, many tons of rope, and you can hold it, right? Because friction will support you in that particular case. But in that particular case, if you want to pull it up, it is going to be difficult. That's secondary thing. But if you want to hold, you can just look at some rod and you can make some rounds of thread, rope, and you can handle it, right? So this is the whole point. So why the difference in tensions came? Because there is friction between pulley and string. So if there is friction between pulley and string, tensions on both sides are not going to be same, but the ratio is going to be somewhat simpler ratio, which is e power mu theta. Now you can see if mu is 0, t2 equal to t1, which is general result what we will be using, right? Yeah, thereafter if you want to solve the question will go like this. You will be writing F equal to ma, but both tensions are not same. So t2 by t1 ratio you will be knowing, e power mu theta, and you will be solving it. Now the next question you need to find, I think everything is there in the figure itself. You need to find acceleration of body 2. So this is how the FBD looks. You have to draw FBD separately. I just drawn here. So there will be weight and there will be tension. If this tension is T, then this tension also will be T, as we explained earlier. And this pulley is massless, so this tension has to be 2T. If this tension is 2T, this tension will be 2T. And this mg cos theta I didn't draw, normal also I didn't draw, mg sin theta I have drawn, because I am trying to see like if this goes down, this one will go up. So I am just looking at direction of motion only. So if this is going down, then I can write F equal to ma for this one. Now if this is going up, then I can write 2T minus mg sin theta equal to m into a. Now how many variables are there? T, a2 and a1, but I have only two equations, so I need to get one more equation. What is that equation? That is relating a1 and a2, which is constraint relation, that is the string is inextensible. Now if this goes by distance x1, then this one will go down by distance x1. If this goes down by distance x1, this part and this part, which is x1 and x1, will appear here. That is, this will go down by 2x1. So if this goes up by x1, this will go down by 2x1. So if this acceleration is a1, this acceleration is 2a1. a2 equal to 2a1. So there are, now you need to concentrate on only these three equations first. So if you have clarity over how we have written these three equations, then you will be getting the required answer. Thereafter it's only about solving. After solving the equations, you will be getting the required answer. Now solving depends on person to person. I don't say like I am good at that. So you have to concentrate on these three equations. Only if you understand these three equations, try to solve the remaining part. If you didn't understand these three equations, try to do it by yourself. If you are not getting, just leave it, but no need to do this. Concentrate on only these three equations. Now the next question, you need to find what is the acceleration of rod and wedge. Mass ratio is given as 1:n. So anyway, so the first thing is, I can predict what is the direction of acceleration of B. B in this case, B can move only along this direction. That I can see. Normal is going to be along this direction. So normal is horizontal. I know it is moving horizontally, and in which direction, either this direction or this direction, that I can predict easily, because normal will be this way. It will try, its component will try to push wedge B in this direction. So wedge B is going to go in this direction. This rod A is going to fall in this direction. That I can predict. But apart from that, what is the constraint? The constraint is they will be in touch every time, right? This acceleration along the normal can't be more than this acceleration along the normal. They must be equal, because they are rigid bodies. It can't compress or they can't be gap. So both accelerations must be same along the normal. That is if this is alpha, then this is 90 minus alpha, this is alpha, that is AA cos alpha. AA cos alpha is the acceleration along the normal for A, equal to AB's component, which is AB sin theta. AA cos alpha equal to AB sin alpha. AA cos alpha equal to AB sin alpha. What is this? This is the constraint. Maybe you people may call it as wedge constraint. The other way of saying it is they will be in contact. The meaning is their accelerations will be same along the normal. Now, after that, I have drawn some free body diagram here. You need to understand that this green color things are written for rod, its weight, and normal from the wedge. Now, these red color things are on the wedge, normal from the rod, and normal from ground and its own weight. Now, for rod, I am going to worry about vertical forces because there will be horizontal force by these walls also, which I didn't put because those will be cancelling the normal's horizontal component, right? So I'll be looking at net vertical motion for this rod. Now mg minus n component, mg minus n cos theta equal to mass times of its acceleration for rod A. Now for block B will be going, wedge B will be going in this direction. So normal's component is the only horizontal force. Normal sin theta equal to mass of the wedge times acceleration of the wedge. So these are the three equations because we have three unknowns, normal, AA and AB. So we have written three equations. Now you need to pay attention for these three equations. If you understood these three equations, then everything is done. If you didn't understand, try to get by yourself. If you are not getting these equations, don't waste time in solving them. Solving is not the important part. Now the next question goes like, prism of mass m1 with an angle alpha rests on horizontal surface, bar of mass m2 placed on the prism. So you need to find what is the acceleration of the prism. So this is the situation. This is the prism and block is placed here. Now what will happen? This will try to go down. When it is trying to go down, there will be normal acting on the wedge. So it will try to push the wedge this direction also. So wedge will be going this way, block will try to go down at the same time, like it will be coming with wedge. And this motion you can't predict, you can't see it easily, you can't plot it easily. But what I can say its acceleration with respect to ground. Its acceleration with respect to ground is nothing but wedge acceleration plus its acceleration with respect to wedge, right? I mean, that's a simple vector notation, right? If I want to find what is its acceleration, what I can see it's nothing but wedge acceleration plus its acceleration with respect to wedge. So that is, if wedge acceleration, if I assumed it as A, then this acceleration is going to be wedge acceleration plus acceleration with respect to wedge, because I know with respect to wedge its acceleration will be only along the incline. So if wedge acceleration is A, then I can find this acceleration as wedge acceleration plus acceleration with respect to wedge. So that is the first thing, that is vector addition, right? So acceleration of wedge plus acceleration with respect to wedge will give me actual acceleration of block. Now, these two values must be same, acceleration of wedge. This I don't know, so I am taking it as different. Now what I have done here is I have written this equation. I'll try to explain what is this equation. This equation says center of mass won't be accelerating along horizontal because the internal forces, all the external forces are only vertical. All the external forces, normal by the ground, weight, all those stuff are only vertical. So acceleration of center of mass along horizontal is 0. That is m1 a1 plus m2 a2 along horizontal must be 0. When you do that, you will be getting this equation. How I got this equation? By knowing center of mass won't accelerate along horizontal. Now, how many unknowns are there? There are two unknowns, capital A and small a. So I need to write one more equation. Because if there are two variables, I can't solve two variables using one equation, right? So I need to write one more equation. But earlier I used to write draw free body diagram and stuff. But now I am not going to do it because I know if I am drawing the free body diagram, I am bringing the unnecessary variable normal reaction. So I am trying to skip it. I am trying to write the equation without any normal reaction. That's how I can do by writing force equation perpendicular to the normal. So I will try to see what is its acceleration along this direction. It is A, small a minus capital A cos theta. That is mg sin theta is the only force which is driving it. Mg sin theta is equal to mass times of its acceleration along this direction, which is A minus capital A cos theta. Now this is force equation for this block along the incline so that I can avoid normal's component. Now these are the two equations. Solving them is in your hands. But try to understand these two equations. What is this equation? Center of mass is not moving in the horizontal direction. What is this equation? F equal to ma equation for the block along the incline with respect to ground. Now, it's the same thing, it's the same question, but here I have drawn the free body diagram of this one. Free body diagram of this one, I can show you normal by the wedge, its own weight, normal by the block, normal by the ground, its own weight. Now, I have written n sin theta equal to ma, that is why it is accelerating, why the wedge is accelerating along horizontal, because of normal's component. This is for wedge. Now, similarly, I have written other equation, that is mg minus n cos theta, that is for this block along this vertical direction, mg minus n cos theta, mg minus n cos theta. Why I have done that is so that I can avoid this component. So what is the acceleration along this direction? It is only a sin theta, a sin theta. So net force along this direction equal to mass times of its acceleration along this direction, which is a sin theta, because this component will be 0. Now similarly, n sin theta equal to ma cos theta minus ma. So n sin theta, that is the horizontal force. What is the only horizontal force on this one? I mean, I resolve like vertical, right? This is the vertical F equal to ma equation. So I am going to write horizontal F equal to ma equation. So n sin theta equal to mass times of acceleration along this direction. What is the acceleration along this direction? A cos theta minus capital A. A cos theta minus capital A. So this is for block. This is for wedge. This is for block along vertical. This is for block along horizontal. You can see I brought n into picture, so I had to write 3 equations. Previously I didn't bring n into picture, so I have to write only 2 equations. Now solving them is in your hands. Now there is no single way. You can see there is other equation also where I brought normal again. Now here I tried to avoid small a in the first place. I didn't bring small a into the equations. I just tried to bring only capital A. Now how I brought capital A? N sin theta equal to ma, that is for wedge. Y is wedge accelerating along horizontal. Now in the next case I am trying to avoid small a. How I can avoid small a equation? How I can avoid small a equation? By writing F equal to ma along this direction, because a is going to be perpendicular to it. So I am going to write F equal to ma along this direction. What is the acceleration along this direction? That is capital A. Okay. How much capital A is sin theta, right? Okay, this is theta. Yeah, you can see that. So if this is theta, then this is going to be theta, this is going to be 90 minus theta. So A sin theta. So what is the net acceleration along this direction? It is capital A sin theta. So what is the net force? Mg cos theta minus n. Mg cos theta minus n, that must give me A m into A sin theta. What is this equation? This equation is F equal to ma equation along this one. Why I have done that? So that I can avoid small a and I can settle down with only 2 variables, so that I can eliminate them easily and I can get the required answer. Now the next question, a ball of mass m is suspended from a bar of mass m with a light inextensible cord. The bar can slide on a frictionless slope of inclination theta. Initially the bar is held motionless, so that the ball also stays motionless as shown in the figure. Find the accelerations of the bar relative to the ground immediately after the bar is released. Immediately after the bar is released. So the FBD looks, I didn't draw the FBD, but immediately after releasing, this will try to go this way. Now the only forces on this one is vertical, either mg or tension just after release. So it can go only vertically. It can go only vertically. But this string will be remaining tight, or their accelerations along this string has to be same because it is inextensible cord. So if this acceleration is capital A, this acceleration is small a. Now what can be the relation between those two? This acceleration component along this direction, which is A capital A sin theta, must be equal to small a. This is constraint relation. This is constraint relation. Now what I need accelerations. So I got constraint relation. So I don't want to bring any other variables like this tension or this normal. So I am not going to draw the free body diagram. I am trying to see why is the system moving along this direction. I am trying to write F equal to ma for the system along this equation. So what is the net force on the system along this direction? There are weights are along these directions. And this tension is going to be internal force. Normal is along this direction, so normal's component is going to be 0. So the only thing I need to concentrate is weights component. Weights component is the only force which will be surviving when I resolve the components along this direction. Now that is capital M G sin theta, small m G sin theta. So capital M plus small m into G sin theta. This is the net force on my system along this direction. That equal to total mass times acceleration of center of mass, right? Net force along some direction equal to total mass into acceleration of center of mass, or total mass into acceleration of center of mass along that direction. What I can say, it is m1a1, which is along that direction, plus m2a2, which is along that direction, right? So m1a1 along that direction plus m2a2 along that direction, right? So that is m1a1 along that direction plus m2a2 along that direction. This is, if this is a, small a, then this is going to be small a sin theta, small a sin theta. What is this equation? This equation is net force equal to total mass times acceleration of center of mass, or net force along that direction equal to m1a1 plus m2a2 along that direction. Now the variables are small a and capital A. I had one more equation also, so I can put it back and I can get the required answer, right? So I am trying to reduce the number of variables. That's the only thing, right? Now the next question. A weightless inextensible rope rests on stationary wedge forming an angle alpha with horizontal. One end of rope is fixed to wall at point A. A small load is attached to the rope at point B. The wedge starts moving to the right with constant acceleration A. So the wedge is moving with constant acceleration A in this direction. You need to find what is the acceleration of the load when it is on the wedge, So only wedge acceleration is given. They are asking you to find what is this acceleration. Now this acceleration, I can break it into two parts. Acceleration is a vector quantity, so I can see it like acceleration of the wedge plus acceleration with respect to wedge. Acceleration of the wedge is small a given, so acceleration of the wedge is acceleration of wedge. Now apart from that, acceleration, now forget that this is small a. Now I will show you like why it is small a. So I can look at this acceleration like acceleration of the wedge plus acceleration with respect to wedge. Acceleration with respect to wedge will be along the direction, along the incline only. That you people must be knowing, right? So I can see this acceleration as acceleration of the wedge plus acceleration with respect to wedge. Now my aim is, I assumed acceleration of the wedge is a. So this is a. Now my aim is to prove this is also going to be a. For that, what I will be doing, I will be observing from wedge. So if I am observing from wedge will be at rest. But this point, this wall will be moving with acceleration small a. Now this thing I assumed, because of this is also going to be small a. If this is small a, when I am observing from the wedge, then this is also going to be small a. The meaning is this point will be moving with acceleration a. So if this point is moving with acceleration a, then this will be moving with acceleration a in the upward direction, right? So what I assumed this acceleration is a. After that, I am trying to see this acceleration as acceleration of wedge plus acceleration with respect to wedge. Acceleration of wedge is fine, but acceleration with respect to wedge is also going to be small a. That I have proved by observing from wedge frame. So by shifting the frame, it is going to be very easy for you to understand this is going to be small a, right? Thereafter, what is the net resultant? Net resultant is resultant of these two vectors, which is making an angle 180 minus alpha. There are two equal vectors and the angle between them is 180 minus alpha, so you can find the resultant, right? So the next question is, in the arrangement shown in the figure, now it's the extension of previous question. You need to find what is the acceleration of the wedge. Now just now you have seen like, if wedge is moving, then you can look at this body like, you can look at this acceleration like wedge acceleration plus acceleration with respect to wedge, and both will be turning out to be same in magnitude as we have seen earlier. So I can see like normal will try to push it this way, so wedge will try to go this way. So I am assuming wedge acceleration is here, so I am looking at this acceleration as wedge acceleration plus acceleration with respect to wedge. This is also going to be the same a which we have seen just in the previous question, right? Now I am looking at this entire thing as my system. The only horizontal force is tension, so net horizontal force equal to total mass times acceleration of center of mass along that direction, or total horizontal force equal to m1a1 horizontally plus m2a2 horizontally, right? Total force equal to m1a1 horizontally plus m2a2 horizontally. This is F equal to ma equation, especially looking at center of mass thing, right? Now how many unknowns are there? T and capital A. Now I'm going to write one more equation which involves t and capital A, but not any other thing. How I can do that? I can look at this block and I can write f equal to ma for this block along this direction so that I can avoid the normal. So if I write f equal to ma along this direction, mg sin theta minus t equal to its mass times its acceleration along this direction. Its acceleration is capital A minus A cos theta. Capital A minus A cos theta. So those are the two equations. The first equation is f equal to ma, or total force equal to mass times of acceleration of center of mass. Now the second one is for the block along the incline from ground frame, right? So these are the only two equations you need to pay attention for. Thereafter it's only about solving. I try to avoid bringing normal and stuff into the equations, right? So the next question goes like, there is a ring and there are some threads like this connected, and you can release the bead. Yeah, all are frictionless. You can release the bead on any thread. So what is the time taken from here to here, from here to here, from here to here? Now which time taken is going to be minimum? That's the question. Now, so what we'll be doing, we'll be taking some generalized situation where the angle is theta. We'll see like for what angle it is going to be maximum or minimum, right? So for this angle, now you can see if this length is 2r, when you make a triangle here, this is going to be 90. So if this length is 2r, then this length is going to be 2r cos theta. This length is going to be 2r cos theta. Now initial velocity is 0, you are just leaving it. So acceleration due to gravity is g this way. So mg will be this way. So what will be its component? Mg cos theta. So what is the acceleration? G cos theta. So this length is 2r cos theta and the acceleration is g cos theta. So when I apply s equal to ut plus half a square, I will be getting cos theta cancelled. So t will turn out to be constant value. The meaning is for all these paths the time taken will be same. For all these paths the time taken will be same. So that's the crucial thing, which is like time taken for free fall that you can see, right? Okay, you can try to solve this question. Again, there are many ways. I'll be doing it based on the previous question what we have discussed. So in the setup shown, a thread is taut between nail A on the wall and nail B on the inclined plane. You can change the length of the thread by changing the location of nail B. So a bead that can slide on the thread without friction is released from nail A. What length should the thread be so that the bead reaches nail B in the shortest time? So that's like what I am trying to do here is I am trying to draw some circle which includes this point. So I will be drawing some small circle, some big. So I can see like the first time it will be touching at this point. So I will be trying to draw a circle where this line will become a tangent for that circle. Even I can say like for sphere also that works the same way. So now from the previous argument I can say like the time taken from here to here will be same as here to here, will be same as here to here, will be same as here to here. So I can easily show you the time from here to here is obviously more than the time from here to here, because this time will be same as this time. So this is extra time, right? So this is also extra time. This also needs extra time. So out of all these paths, which one will take minimum time? This is the one which will take minimum time. So now this angle is theta, so this is going to be 90 minus theta, and this is perpendicular, so this is 90 minus theta, this is 90, so this is theta. If this is theta, this is 180 minus theta, so this is theta by 2, this is theta by 2, because that is isosceles triangle. So you can draw all those, and I plotted ABC, this triangle. You can see ABC triangle where this length is h and you have to find this length, so you can use sine rule, right? So you can use sine rule for the triangle where AB by sine of its opposite angle, sine 90 minus theta, equal to h by sine of its opposite angle, which is sine of 90 plus theta by 2. So from there we will be getting value of AB. So the next question is also extension of the same thing. A rigid triangular frame ABC made of a thin rod is fixed in a vertical plane. The angles between the rod segments at corner B and C are 74 and 55 respectively. A small bead starting from rest from corner A takes equal time to slide AB and AC. There is no friction between the bead and the arms. Find the angle theta which the arm BC makes with horizontal. So what they said is, they said the time taken from here to here will be same as here to here. So the meaning is all these 3 points must lie on single circle like this, right? Now you know if there is a line segment which is making 74 degrees on circumference, it will make 74 degrees on any of the circumference points. So this angle is turning out to be 74. if I take this triangle which includes this horizontal line. Thereafter you can do many things, either you drop a perpendicular, or you can see like you have to see that this is going to be isosceles triangle. So if this angle is 74, this total angle has to be 74, which is 55 plus theta is 74. So from there you will be getting theta is 19, right? The next question goes like, there is 1 kg block, there is 2 kg block, there is no friction here, there is friction here, whose coefficient is 0.5. So the question is, with what maximum force I can pull 2 kg block so that they can move together, that is there is no relative motion. For that, the first step I am going to do is, I am trying to draw the FPD. There is weight and normal from 2 kg block, which is exactly equal to weight because it is not moving along vertical direction. So if this is 1g, then this one also will be 1g, which is exerted by 1 kg on 2 kg. Now if this is 1g and weight is 2g, then this normal will be 3g because it is not moving along vertical. So if this is 3g, this one also will be 3g. That you people must be knowing, so I am not going to explain. I am trying to pull 2 kg block. So if there is no friction, 2 kg block would have slid this way. So if friction is there, what will happen? Friction will try to move this one forward and move this one backward, or it will try to support this motion and oppose this motion. It will try to support this motion and oppose this motion. Now the thing is, I can move 2 kg with whatever acceleration I want, because I can vary this force, but there is a limit for what is the acceleration of that 1 kg. So we are trying to see what is the limit of that 1 kg's acceleration. For that I need to see who is going to move friction. So for this acceleration limiting I need to know, so I need to find what is the maximum friction force. Maximum friction force is mu times of normal there, mu times of normal, which is 5. If maximum friction is 5, what can be the maximum acceleration? It is also 5. If the maximum acceleration of 1 kg is 5, what I can conclude? I can conclude both can move with a acceleration 5 together. So both can move with the acceleration 5 together. So if both are moving same acceleration, I can say net force equal to mass times of acceleration, which is 3 times of 5, 15. So till I apply 15 Newton force, they will move together only. The meaning is, if I apply less than 15 Newton, that is if I apply 10 Newton, then they will be moving together with acceleration 10 by 3. If I apply 15 Newton, still they will be moving together. If I apply more than 15 Newton, so let me say 20 Newton. If I apply 20 Newton, then what will happen? This will be moving with acceleration 5 only. This will be moving with acceleration more than 5. Now you can do it for practice by yourself. Now instead of applying force on 2 kg, I am trying to ask the same question. What must be the maximum force? What can be the maximum force that I can apply on 1 kg so that they can move together? Again, I will be drawing the FBD. And I will be finding, now I need to figure out what is the maximum acceleration of 2 kg. What is the maximum? So for that, maximum friction on 2 kg is 5. So maximum acceleration of 2 kg is going to be 2.5. The meaning is, till acceleration of 2.5, they can move together. So if they are moving together, I can treat it like 3 kg block with acceleration 2.5. So that is, I can apply a force of 7.5. So in this particular case, till I apply a force 7.5, they can move together. If I apply more than 7.5, there will be slipping, where 2's acceleration will be 2.5, 1's acceleration will be more than 2.5. Now the next question, I will be doing it in parts. I will be doing a Swan part now and crawfish part during rotation. So anyway, let me go into the question. The question is like, Swan can move if there is an object like this where the friction coefficient is mu, which is generally less than 1. So if I want to pull it up, I have to apply at least more than or equal to mg, right? So if I want to move it this way, just by pulling it horizontally, I have to apply at least mu mg. Now I will be trying to show like I can move it along this direction by applying force less than mu mg. So for that, what I will be doing, I will be applying force at an angle. Why I am doing this? So that I will be having some component which will be trying to pulling it, and there will be other component which will be trying to reduce the normal. Reducing the normal meaning reducing the friction also. So I am applying force at an angle so that I can reduce friction, as well as there will be some force in the horizontal direction which can pull it. So I am resolving this force, f sin theta, f cos theta, weight, normal, friction. So from here I can write one equation, net vertical force is 0. From here I can find normal. Now when it is just about to move, this force must be equal to friction, that is along horizontal. So try to understand these two equations. Now when it is just about to move, this force must be equal to that maximum friction. Maximum friction is mu into n value is mg minus f sin theta. So from here, if I try to find f, I will be getting this much. But if I want to find f minimum, this denominator has to be maximum, whose maximum value is root of 1 plus mu square. This is a very regular question you will be doing in the class. Now let me just put mu equal to half, then f minimum is 1 by root 5 into mg. So mu mg is mg by 2, but this is even less than mg by 2. So even by applying less than mg by 2 or mu mg, by applying less than mu mg, still I can move the block in the horizontal direction. That's what Swan does. Now the next question, two identical elastical cords of negligible relaxed lengths. The important part of the question is negligible relaxed lengths are tied at one of their ends to fixed nails A and B that are equidistant from origin. So this distance is same as this distance. The other ends of strings are tied to a small ball to hold the ball in equilibrium at point 4, 3. A force of magnitude 1000 Newton is required. Assuming the space conditions, find the time constant of the cords. So whenever natural length of the string or spring is 0, try to put it in vector form. That is going to be much simpler. Remember this. So if the natural length is 0, the extension of this cord is same as this length. And what is the direction of force? The direction of force will be this direction. So I can write this string force or spring force in vector form as k into PA bar. K into PA bar. That is k into its extension and in this direction. K into AP and the direction is PA cap. And what is the force by this one? K into PB and PB cap. So K into PB bar. This is spring force by this one. This is the force by this one. But there is some other force, so that the net force will become 0, right? So this force plus some other force, the net force is 0. So I need to find the net force because that is given in the question, right? So I am trying to put it this way. I am trying to take this one to the right hand side. So this PA bar will turn out to be AP bar. This PB bar will turn out to be BP bar. Now AP bar in this figure is, I am assuming this as X bar and this as R bar. So if this is X bar, this one is also X bar, right? So AP bar is X bar plus R bar. AP bar is X bar plus R bar. Now similarly, BP bar is X bar plus BP bar equal to R bar. So BP bar is R bar minus X bar. R bar minus X bar. So when you solve it, you will be getting force is 2K times of R bar. R bar is 3I cap plus 4J cap, right? Something given in the question. 4I cap plus 3J cap. Anyway, we need only magnitude. So I can say force magnitude is 2K times of R. R is 5. You can substitute. You will be getting the required answer. But remember, when the natural length of the string or spring is 0, it's always comfortable to write in vector notation. So the next question goes like, a small disk A is placed on inclined plane forming an angle alpha with the horizontal. This is alpha with the horizontal and is imparted an initial velocity V0. Find how the velocity of the disk depends on angle phi if the coefficient of friction k equal to tan alpha and initial moment phi naught is pi by 2. So the meaning is phi naught is pi by 2 in the sense you are projecting perpendicular to this line. So like this, you are projecting it like this, and after some time it is coming here. You need to find what is its speed depending on this angle. That's the given question. So you are projecting it this way. After some time it has reached here where this angle is phi and this speed is we have to find, right? So I am trying to see what all accelerations are there, what are the forces along the incline. One is mg sin alpha, the other one is friction. Friction will be opposing the relative motion, that is opposite to the velocity. Mg friction will be maximum, which is mu into n. N is mg cos alpha here, mu value is tan alpha here. When you substitute, you will be getting friction value as exactly mg sin alpha. That's the tricky part of the question. Friction is turning out to be exactly mg sin alpha. You can see this is also the same. Now obviously the general tendency will be I will be trying to see at what rate this is increasing, so that I can integrate and stuff, right? So at what rate this is increasing. So dv by dt equal to, what is the net acceleration along this direction? This g sin alpha cos phi minus g sin alpha. G sin alpha cos phi minus g sin alpha. So but there is a problem, like if I want to integrate it, then cos phi is varying. I don't know how it is varying. So integration is not going to be a feasible thing, just like that other question what we have done in kinematics, right? So I will try to do something. I will try to write some other equation which involves cos phi so that I can delete it. So how I can include cos phi again? Now previously I have taken this component along this direction. That way I will be getting cos phi. So if I take this component along this direction, again I will be getting cos phi. So what I will be doing is I will try to see at what rate the speed along this direction is changing. That is, what is the speed along this direction? V cos phi. The rate at which V cos phi is changing is g sin alpha minus g sin alpha cos phi. G sin alpha minus g sin alpha cos phi. Now I can see I got the, this is cos phi. This is cos phi, not alpha. So I'll be getting the similar things just with one negative sign. So if I add these two terms, I'll be getting 0. So the left hand side will become, if I add these two, then I'll be getting right hand side as 0. This is x dash plus y dash, so x plus y whole dash. Now if differentiation of something is 0, it must be constant. So this is at any moment, this is at initial moment. So at any moment speed will be initial speed by 1 plus cos phi, right? Sir, new video.